This is the screencast for section 1.5, example 5, the inverse reflection principle. So I mentioned before that when you take the inverse of a function, everything with x and y switch. So in other words, if you had a point 1, 3, now that point is 3, 1. Which means every single point is going to reflect across the line y equals x. Now the reason why y equals x is the line that everything reflects across is because if the y coordinate equals the x coordinate and you switch them, it's still the same point, so it's going to stay in the same place on the coordinate plane. So for example, 3, 3, if you switch the x and y, it's still 3, 3, it's staying in the same spot. Example 5 says finding an inverse function graphically. The graph of the function y equals f of x is shown in figure 1.68, that's this. Sketch a graph of the function y equals the inverse function of f. Is f a one-to-one function? So the question is, what's a one-to-one function? Well, a one-to-one function means that it's a relation that passes both the vertical line test and the horizontal line test. In other words, it is a function and its inverse will be a function. So there is only one x value for every one y value, and vice versa, every one y value for every one x value. So step 1, let's sketch the inverse of this function. Well, since this graph is going to reflect around the line y equals x, I'm going to sketch in that line y equals x to give me a frame of reference. Now I can also look at this numerically. The point, let's see, on the original function 0, 1 was a point, so now on its inverse 1, 0 is going to be a point. On the original, -1, 0 was a point, so now 0, -1 will be a point. This point right here is going to stay the same. And then these three little points can kind of give me some help when I sketch the inverse of this function. I can see this piece, as it gets reflected around the line y equals x, is going to go away. So I'll do something like that. Then this little piece in here has a little scoop, and then I'm going to cross through that line y equals x and move away from it in the other direction. So graphically, this is my this is the inverse of the f function. So then the question is f one-to-one? Well, f, the original function, does pass the vertical line test, and it passes the horizontal line test. So yes, f is 1-to-1. F is a function and its inverse is a function. The now try problem, number 23, asks us to determine whether the function is 1-to-1. If it's 1-to-1, sketch the graph of the inverse. So this function passes the vertical line test. It also passes the horizontal line test. So yes, this is a 1-to-1 function, so now we can sketch the graph of the inverse. I'm going to draw y equals x as a basis for my reflection. And then I'm going to try and sketch the opposite of what's going on, so on the other side of that line. Let's see, and then over here, it's very close. So now, since I could draw the reflection of the original function, I have a sketch of the inverse function of f.